Hi everyone, I'd like to add a couple more shortcuts to our list. So let's see, let me show you our list so far. We have the constant function, linear function, power rule, and exponential functions rules. So what I want to get at now, I don't actually want to add any more functions, but I want to be able to do other things to these functions. So for example, one of our goals is to be able to take derivatives of polynomials. Right now, I could take the derivative of x squared with the power rule, but I wouldn't know how with our rules to take the derivative of 2x squared minus 5x plus 3. What do I do with the plus and minus? What do I do with the extra numbers out in front? So that's what I want to work on here. So first thing, I want to do the constant multiple of a function. So this is going to be even a little bit more general, kind of like the constant and linear functions we did earlier. So we want to know what is the derivative of a constant multiplied by some function. And the assumption here would be that we know something about the derivative of that function. So the only way to find this out, and I don't plan on asking you to reproduce this, but my rule is I want you to see where it's coming from. So I want you to watch and try and follow along and understand what's going on here. Once we've done this once, you get the shortcut for free, so you won't have to keep doing this over and over again. Okay, so this entire thing is now our function. So we're supposed to take our function evaluated at x plus h. The x plus h doesn't do anything to the constant. It just goes inside that function. And then we're supposed to subtract off our original function, c times f of x, and we're supposed to divide by h. And the idea here is not to actually get like an equation. There should be f of x's or f primes in the answer. What we're really hoping for, in fact, is f primes. How is the derivative of the constant times f of x related to the derivative of plain old f of x? So here, the way we do it is we just factor out a c. And then it's important to notice that c is just a constant. So regardless of h going to 0, c is going to be c, which means the c doesn't really have to stay inside of the limit. The limit isn't affecting the c, so it can get moved out in front of the limit. And we could just say, well, if we could figure out what's happening to f of x plus h minus f of x over h, then we could just take that and multiply it by the c. And this is actually very convenient because the limit as h goes to 0 of f of x plus h minus f of x over h is f prime of x. That is the derivative of f. So to add to our list of shortcuts, I have number 5. The derivative of a constant times a function is the constant times the derivative of the function. So this is the constant multiple rule, not to be confused with the constant function rule. This is a really important difference. People mix those two up. So a lonely constant, just plain old 2 or 7 or 1/3 or whatever, its derivative will always be 0. But if it's a constant multiple of a function, basically what we're saying is how do I want to say this? This is asking for the slope of c times f of x, and this is saying it's c times the slope of f of x. So by multiplying all of your y values of your function by c, doing vertical stretch or compression, you just multiply your slope by c as well. It just makes it that much taller or shorter. Okay, the other one, just one more really, it's kind of two, but I'm only going to walk through one version, is the sum or difference rule. So we'll just go through I think I did the sum, yeah. Okay, so I want to know what the derivative of f of x plus g of x is. So if I have two functions whose derivatives I know, can I figure out the derivative of the sum of those two functions? So we go back to our limit definition, and we get first our function, which is all of this, f plus g, evaluated at x plus h, and then we need to subtract off the original function, f of x plus g of x, sorry for the squeeze, all over h. And our goal is to figure out how this relates to f prime and g prime. So really we're just going to do some rearranging here. And we're going to get together the pieces that look like they should go with an f prime and the pieces that look like they should go with the g prime. So I see my f of x plus h minus f of x. So I got this and this grouped together. And then I have my g of x plus h. And when we distribute, I do have a minus g of x. And all of this is over h, but I can actually do even better. I can say, well, it's always legal to split up the numerator of a fraction. To get back to where we started from, I would just say, well, they already have a common denominator, so add them together, add the numerators together and put it over h, and that would get me exactly here. Which means that what I have is an f prime plus a g prime. As h goes to 0, those will just become the derivatives. So the sum rule and the difference rule works out equally smoothly. So I'll just give them both to you, is that if you have f of x plus or minus g of x, the derivative will be f prime of x plus or minus g prime of x. And again, these are situated the same way on purpose. If there's a plus on the left, there will be a plus on the right. And if there's a minus on the left, there will be a minus on the right. So this is the sum or difference rule. Another way to get the difference without going back to the limit definition would be to say f of x minus g of x is the same as f of x plus -1 times g of x. And you could use a combination of the sum and the constant multiple. Okay, thanks for watching.